All right, so today we're going to recap APIs and web scraping. I'm just going to go through 2 examples each for APIs and web scraping. I will say, like, a really good way to test if you're good at reading documentation or, just figuring things out as a whole is seeing if you can figure out how to work on an API on your own. Every API and every website is different. So these are just examples. Through these fairly simple examples, hopefully I will talk about things to keep in mind for when you're doing APIs and web scraping, as well as some hopefully helpful pointers. And as usual, anytime feel free to interrupt me. So the examples I'm going to go through, I'm going to go through these 2 APIs: Twint for tweets, Spotify for Spotify data, just because these are 2 of the most used APIs for Capstone projects. And then for web scraping, I have an example from Board Game Geek, which is this board game website. It's a special example because their API/website or their information is stored in XML format, which I believe is actually in the appendix of phase 1, which I don't believe many of you have seen. So I will walk through that. And then we're going to do a quick example scraping apartments from Craigslist. Craigslist is a very simple website, but a few like web scraping principles that are important to address when we're dealing with that. So why don't we get started with Twint? Twint again is not the Twitter API, because the Twitter API, I believe you have to actually get. It takes a while for them to give you access or authorization because of all the things going on with Twitter. So therefore, Twint is a great alternative. It was built, I think, a few years ago. And what it's doing is actually scraping Twitter. That's actually how Twint works. There's a couple things here that I need to point out that if any of you want to like dive straight into getting Twitter data will be helpful. So yeah, I've linked the documentation up here. This is the Twint documentation, and on their documentation page, a lot of examples, and you can basically really quickly see like what kind of information you can get. This text looks kind of different from what we're doing because this is actually their command line tool. So you can actually just get it from your command line, have it automatically port to a CSV, but I'm just going to walk through how you can do it through a notebook. One disclaimer, as I was throwing this code together, because I have used Twint in the past, my code actually broke and I had to like add a bunch of new things because it's consistently being updated. I think in big part due to like Twitter's new like guidelines and everything that's happening with their company. So yeah, I'll just talk about a couple of the things that I had to add and my guesses for why I had to add them. So to use Twint, really simple. You just have to import Twint. You might have to do a pip install. Some of you, if you're working in your Learn environment, if you have dependency issues, which has come up with multiple different libraries for some of you. To go back to quickly talk about the Learn environment was there such that you all will have most of the packages pre-installed. Feel free to get out of the Learn environment. And actually, to get out of your Learn environment, all you have to do is do conda activate in your terminal, and then you are no longer in your Learn environment. And as you see here, I actually don't use the Learn environment too much. It is my Python 3 kernel rather than the Learn env one. So if you are experiencing any issues with like dependencies or things are not installing properly, I think a lot of people were having issues with Facebook Profit in this cohort as well as my other cohort. So yeah, just know that if you're having like weird installing issues, Learn environment could be a thing, just because in the Learn environment, there are specific versions of packages, some of which are outdated, which pros and cons of the Learn environment, but yeah. So yeah, import Twint. This other thing, Nest async IO. This is needed for some reason because when I tried to run Twint, and this wasn't the case about a year ago, it's trying to like it's trying to execute some sort of loop outside of itself. That was what the error message said. Not sure what that is, but you have to also import that for it to run correctly. So with all of this, oh, and this apply basically applies whatever this async IO thing is. I don't know what it is either, but it got it to work. So if any of you are using Twint, don't forget this portion as well. For some reason, needed to execute the API call. All right. Now, the way I like to describe this is sort of like object-oriented programming. So here you're instantiating a Twint object, a Twint configuration object. And C, so within C, you have all of these different attributes. And the attributes basically will tell you how to run your search. So as you can see here, just as a quick example, my search term is COVID, and I know that's gonna probably yield a lot of results. If I want to like only get tweets with a certain number of likes, so that maybe they're, you know, tweets not just by like random people, at least 10 likes. Actually, I could put 100 even. This I think will, I forget what the count does, to be honest. I forget what that one is, but the documentation might say somewhere. I'm not going to go through it right now, but you can limit to 100 tweets for your project. You probably want more than 100 tweets. And you can also have it automatically store as a CSV. And this is going to be my output CSV. So with all of this done, and you can see here, this is sort of like attributes of your C object. There's a bunch more that you can add. There's a lot of, I believe there are also a couple of Medium walkthroughs. This notebook, by the way, is not yet on your repo. I'm going to keep taking notes as I'm walking through this and then upload the notebook after the session. But yeah, so after we run all of this, nothing's going to output just yet. We'll have to run this run search method. So when we're doing that, a lot of stuff usually outputs. So you can see this is all the stuff that's being taken off of Twitter right now. And I think, yeah, this is today, which is great. This was in the last, yeah, these are all within, like this was literally 6 minutes ago, which is pretty cool. But we've run this search. You can see that in my home screen, where's my Jupyter home screen? Here. In my Jupyter home screen, you'll see that we have now a COVID tweet CSV file that we can read. So if you read our CSV file, you can see we have all of this information about tweets right off the bat. There's also a way to, you know, not get all of this information. It is also one of the attributes that you get to edit, but straight off the bat, in like a second, literally, I have 100 tweets. And probably what you're going to take is the, let's see, where's the actual tweet? Let's find out. So tweets, oops. And then let's do tweets.columns to find out where the tweets might be. Let's see, it's probably in tweet. There we go. So we go tweets. There we go. So these are this is the body of your tweet. So yeah, Twint makes the Twitter API easier to use. I have had students use the actual Twitter API and they've decided to use Twint anyway. So I have a feeling a lot of you are going to end up using Twitter data. So yeah, this code is here for you. Any questions on this? All right, you can see that for this, we didn't need to have any like sort of API key with tweets. I think something that's important to think about, and this is, again, it's more specific to people who want to use Twitter data. Think about how you want to scope the tweets that you're collecting, because there is a lot of data on Twitter, as you can imagine. There is, for example, you can get like just verified users tweets off of here. You can search up specific users. So yeah, the documentation has a lot of that. And if you look up examples on Medium, there are a lot of good walkthroughs as well. But cool. Any questions before we move on to the next, more similar to an API? Cool. So the next API I'm going to talk about is Spotify. So Spotify's actual API. So Spotify is a Python wrapper of the Spotify API to make it more easy to use for Python. A lot of APIs do have wrappers in this similar fashion. So If you find an API and you find that the syntax is a little hard to use, if the authorization is a little weird, maybe look up to see if they have a Python wrapper or a Python version. Spotify is actually on Spotify API's documentation as an official, not official, but as like a good Python wrapper version for their API. Spotify is a little bit different from Twint because with Spotify, you do have to have like an API key. You do have to have some sort of authorization because it is actually calling using Spotify's API. It's just wrapping it in functions that make it a little more intuitive to use. So the one thing I want to talk about that is different between this one and the last one is storing your credentials. So before you even use the Spotify API, you're going to have to go to their website and create your developer credentials. So this is mine. I actually did a couple mini projects using Spotify, so I have this already. But basically, you can log in on the Spotify for Developers website. You have to create an app to get like an API key. So do that. I already have mine here, Spotify. And oh, let me log in really quick. And as you can see, this is where I can copy and paste my info. Of course, I don't have any other things that are important on this page, but these are the API keys that are important. Now, if you remember, we should not ever hard code our API keys into our notebook or into any Python script. It should not turn up anywhere on our GitHub because GitHubs are public and we don't want people to end up using our API information. It might not even be for malicious intent, but it's still better to use it because your API key is tied to you. So you don't want anyone to just be doing, I don't know, whatever random stuff there. Yeah, whatever. You don't want people to use your API key basically. So if you remember back in phase 1 in the labs, they outline a way that you can store all of your passwords on your computer. I personally like to use a config file. So I'm going to walk through that. But the lab walks through a way of storing it in a secret folder. I think some of you might remember this from working with the Yelp API. But just really quickly, I'm going to talk about this config file. So you can see here, I've put my config file in the same place as my notebook, and my config file has all of my secret information stored as variables. So you can see here config.py, it is a Python file so that you can import it. And I have my client ID, client secret, and this is actually my Spotify user ID. I also use that in a couple of projects, and I'll show the result of using that. So yeah, now that I have that, all I have to do is import config. And there's all these other things that I'll talk about in a little bit. But from config, you can see that within config, I had 3 variables. They were called client ID, client secret, and user. I can use them here. So if I do config.user, I get my user ID. If I do config.client ID, I have that. Client secret, I have that as well. So I'm just gonna get rid of this so it's not on this notebook. But yeah. Any questions about the config file or like storing your passwords?
How do you create the config file?
Oh, yeah. All good, great question. So several ways you can do it. You can do it from your terminal. I think the easiest way to do it, just because it's something that's you literally are just copy and pasting. I actually do it in Jupyter because I am lazy. So I just do new text file. And then here you can just do config. Here I'll just do config2.py. And just as a quick example, let's just say that username equals this is my username. And then password, just as an example, password. So you just have to save this and then you are good. One thing, if you're creating the new file, you probably have to restart your kernel. So I created config2, right? Let me see if this will import properly. Oh, see, it actually imported. Sometimes you have to restart your kernel if you're creating a brand new file or editing your file. So, all right, so from config2, now I have my username, hopefully. There we go. And I have my username and I have my password.
Thank you.
I have a
You're
question.
welcome.
So whenever you upload this to GitHub, doesn't that text file or that Python file also upload?
Great question. I also almost forgot to talk about that. So yes, that Python file should not get pushed to GitHub at all. And I actually don't have a good example here. Let me just quickly show an example of how I would do this. But the way you would not have your config files pushed up to GitHub is by adding it into your git ignore. So because this is not a Git repository, I don't have a git ignore right away, but let me reshare my screen real quick so you can see my terminal. Give me a second just to close all of my tabs and windows. All right, let me do a quick reshare. All right, so now y'all can see my whole entire desktop. So by ls, I have a lot of stuff here, but you can see I have the config file, the config2. I have a bunch of other files, but that's not important. So what you want to do is you want to edit your git ignore. So typically you should already have a git ignore. Like if you were to do ls-a in your, oh, that's weird. I do have a git ignore there. That should not be the case. But yeah, if you do ls.a, if you had cloned your GitHub repository after you created a git ignore, your git ignore should be there. So you can actually edit your git ignore. So since I have one there, I'm actually curious to see what's in there. I can just open my git ignore, open.gitignore. And that happens to open it in a text file. Oh, this is probably here from the last time I did it. As you can see here, I have my config.py. If I want to add more, I literally just have to type in the name of the file, save it. I just did like a command S to save. You can also save it here. And yeah, and that saves. By default, it opens in your default text editor. Mine happens to just be the Mac text editor. You can also open it in like VS Code, in like Atom, in Sublime, Spider, whatever text editor that you like to use. So yeah, the way that you don't let that get pushed up is by adding the file name into your git ignore. Yeah, that's a really good point, Asher. Thanks for asking. Anything else?
Excuse me, Ish.
Mm-hmm.
I remember the other way that we had our file in our local computer.
Mm-hmm.
Yeah. And what was the command when we wanted to open the file in our local computer?
Like just opening like any text file?
Yes. I guess
so
it was starting with M, but I don't remember the command exactly.
Well, to open a text file, it is just open on a Mac. I know on PCs it's different. I honestly forget. I think it might be run. I honestly forget. But if you're doing it in a text, if you're opening it in your text editor, I think it's Atom.gitignore. So I use Atom. Let me just see if this works and it pops up. Sweet. So my gitignore does pop up here and I can edit it there. It really depends on what program you're using to open it up. To open it in your Finder, I like to do open space period, and that just opens everything. So you can see I have all of my desktop files here and I can like just click into it and, oh wait, where's it? The gitignore doesn't show up because it's a hidden file. I forget what the view options are. There's a way to like toggle your view options to show the hidden files, but I don't want to get into that right now. Was that what your question was, or is that something different?
I guess I asked it wrong, but I think how you can create a file by your terminal, yeah.
Okay, yeah. To create it via your terminal, the command is touch. So it's touch. Let me just create a regular file, text.py. And if I do ls, you can see that that is there.
Okay,
yeah, to create it on your terminal is just touch. And then you can open it in whatever you want.
Okay, thank you.
And I'm looking at the comments. You're right. mkdir makes a folder. So make directory is what it stands for. So if I just do that, you can see that if I do ls, I now have a new folder. And then I can actually cd into that new folder. There's nothing in it. All right. Anything else before we move on?
Yeah, quick question about the importing of the local files. if you use the same variables like user, password in both files, would they conflict or would they overwrite one another?
That is a good question. You wouldn't get thrown an error, but I believe it's the last one that you have that will stick. So yeah, you're right in like, so there's a difference between doing the import config like this. So if I just do import config, if I want to use any of my credentials, I have to do config dot whatever it was. Or alternatively, you can do like from config to import user. And then now, oops, oh, username is what it was, username. And then now username is my username. So it does depend on how you import it. If you're just importing the file as a whole, you are able to differentiate the two by just doing like the dot, because those will be recognized as different things. Because if you do config dot whatever versus config to dot whatever, that's going to be different. But yeah, if you import directly from here, you could also import it as something as like U1, and then from config import, let's see, let's just do client ID as U2. Now, if you do this, my U1 and U2 would point to different things. So U1 is here, U2 is here. So yeah, several ways to get around that. That's a good point to bring up.
Thank you.
You're welcome. Anything else? Cool. So let's just play around with Spotify a little bit. I will say that if you're using any of these, it does count as an API, because technically you are using an API, kind of. Or I guess this would be counted as web scraping, but yeah, these count as getting your own data. All right, so yeah, this is just my user ID. So something that you can do with Spotify, a lot of different functions. Let me see if I have the documentation is pulled up. It goes through all of the different functions that you can get. So for example, you can get like artists, artist albums. If you can get a lot of user information as well, such as, let me just scroll down a little bit, such as like user playlists. So the one I'm going to show is I'm going to just get all of my playlists from my account. Probably not useful for you, but just to play around with it. I of course have my user ID here. I'm just using Spotify.user playlist to get it. And because I played around with this code before, I know that it comes back as a JSON format, and everything I want is stored under items. I've also been able to extract each playlist ID. Feel free to like take this code and play around with it with your own information, but you can see here that this is all the tracks of, I guess, one of my playlists on Spotify. Not important to get the details right now, but anyways, what will be more helpful for you all probably is Spotify search function. If you just want to get like a bank of like songs or songs from like an artist or a genre, the search function is probably what you're going to end up using. So, I'm showing you all this because within Spotify or Spotify's API, you actually do have a lot of really cool functionality. Like you can actually create playlists from your Jupyter notebook using Spotify. Something that I did actually a few months ago was I forgot if I told you all this, but I managed to like write a script that would take everyone's like Google Play Music playlist and port them over to Spotify, because that tool exists, but they make you pay like $20 for it. But yeah, that is something that you can do. So maybe your project includes like creating playlists, and someone could create a playlist using your program. So that's why this is here. But anyways, Spotify search is probably going to be more useful for you. Spotify search is very, very easy to use. You can see here, I just wrote a really simple function to look up just a song. If you already have an idea of a song, you can do that. You can take the artist and like the song name. And with that, you can see it takes in a query. And also, I guess you can also limit. So if I want to take 3, we'll see, we'll see what comes up there. So if I do a Spotify search of like levitating, I get all of this information. And then it's up to you to just play around with pandas and decide how you want to store that information. Probably single song lookup is not what you're going to be using. I mean, it really depends. But what a lot of people have done is basically to get a lot of songs from like specific genres, because that's maybe how you want to scope out the data that you get. So the way that Spotify search works is you literally feed it in like, all right, I'm looking up genre. What genre do I want? And instead of limit 1, let's do limit 10. And just like that, you get 10 different songs from the pop genre. So yeah, from here, each song comes with a lot of information. So this is literally all the markets that the song is available or like licensed to be streamed in, which is pretty cool. You have like, I think this is like what album it belongs to, images related to it. This is literally like the name of the song, when it was released, stuff like that. I think if you go to, let me see if they have this here. You have track ID. If you're looking it up for a specific person, if you have like people's user IDs, which I don't remember if that is easy to just get random people's user IDs, you can actually get play count, because I know I can get my own play count from for my own stuff. So if that is something you want to explore, that is available. But yeah, I will not go through how you will wrangle this data into a data frame, because you all should know how to do that. But yeah, regarding this, any questions?
I did have a brief question. Yeah, so like a lot of projects that use Spotify that I found on GitHub do a lot of recommendation systems looking at like track IDs and artist IDs. Yeah. But like you just said, you have your own user ID. And I don't really understand how you would be able to generate like many users without just like randomly typing in numbers to get random user IDs. Doesn't seem like there's like a clear way to get data on different users, but like clearly that information is public, because if I go on the Spotify app, I can just find users in their playlist. So I don't really understand how to get that through the API.
Yep, that's right. I will say like just getting a bunch of random user IDs, I think that there is a repository somewhere with that information that is just a bunch of random users. Because of course you don't want just like a user that doesn't really use the app that much. So I think I do believe that there is a curated list somewhere. I'll look for it, and let me just write that down. I'll see if I can find it. But it brings me to my next thing, where it is a way that you might be able to get the user IDs, is that Spotify's research and development team has actually put out these data sets. And Spotify, they have like different data science competitions actually, I think yearly. I don't know. I think last year they canceled it, I forget. But anyways, they have all of these data sets. So this million playlist data set is a million playlists. And what you have there is you also have who created the playlist. So I think from there, you might be able to get like a set of user IDs.
Yeah, that's just available to anyone. I just was wondering if that really counts as getting your own data, because to me, it seems the same as just like going on Kaggle and dumping a data set into your folder. So like, would that really count as the data requirement? Because these are just available data sets that do have the user IDs.
That's fair. I think for this one, if you're planning to use this, I guess this is considered an off-the-shelf data set, but I think, so the products that I've seen that use this still end up using the API in some way. So the people who I've seen using this still end up using the Spotify to just like get additional information, because I feel like you don't have all of the track information of everything here. So I think even if you use this, you do have to end up using the API still, because this I don't think has like the full information of like every song on the playlist, if that makes sense.
Okay. Yeah. Okay, that makes sense.
Yeah.
Thanks.
You're welcome. If you're deciding to use like one of these, and you're unsure if you're doing enough on like the data gathering side, let me know. We can evaluate it together. It is a little bit of a gray area for sure. So yeah, happy to talk about it during any one-on-ones. But yeah, that's a really good point. So yeah, there are all of these data sets that are here, and up to you what you want to do with that. Spotify also now like has a lot of podcast information, and I believe they're actively working on building out their podcast data and like metadata. I think I recently saw that they like put out a patent to analyze like environmental information in podcasts, which is interesting. I don't know what they're going to use that for, but yeah, I'm excited for their podcast info. But anyways, I digress. Any other questions on APIs before we talk about web scraping?
Excuse me, Ish.
Mm-hmm.
Sorry to interrupt you.
No.
Could you please continue in full screen, please?
Oh, yes. That's a really good point too. There we go. Yeah, that's probably easier for you all to see. All right. Okay, so with that, that closes out APIs. I will say every API is different and every API has different functionalities. Different APIs work better or worse with Python. So, I mean, take it as a challenge for yourselves to figure out whatever API you want to use. But the main things to remember, I would say, are honestly storing your API keys. That's really, really important. People have gotten like blocked or like flagged on GitHub, or you get blocked from the API if they find that an API key is publicly available. So do be careful about that. All right, so let's get into web scraping. I have two like honestly pretty quick examples that I wanted to show you all. One of which is Board Game Geek, and I actually worked with their data before. What took like it didn't take a lot of time for me to figure out, but what was kind of annoying is that it is in the XML format. So Board Game Geek has an API, but it's a very old API. And XML looks like this. Let me just show you all. XML looks like this. It kind of looks like HTML. Whenever you see like the triangle brackets, that's usually XML. And XML was basically the predecessor. Yeah, it came before JSON. So it has structures that look very similar to JSON. You can sort of see there's some nesting going on. So XML is an unfamiliar data type for us. And there are just like certain little things that are hard for me to figure out. It was honestly a lot of trial and error, but I just want to talk about that just in case any of you run into an XML format. So yes, where was I here? All right, so let's just say I wanted to scrape this information. And by the way, this information comes from here. What is this game called? So I can like look up the same game. Let me just run all of this scraping function. Okay, this game is called Samurai. I hope it's this one. Yeah, okay. So this is all the information on Board Game Geek. I actually used this to build a content-based recommendation system because there's a lot of information about like how the game is played, number of players, stuff like that. So as you can see here, not really straightforward to scrape because you would have to click into all of these things to get all of the information. So they do have like an API, but it's fairly outdated. So because of that, I believe, where can you find their API? Well, their API is somewhere on their website, but your API, the API basically shows you that you can get this information. So want to talk about XML format. Back to my notebook. So with XML, what's really neat is that Beautiful Soup has an XML parser. If you remember what we were doing before, we used the HTML parser within Beautiful Soup, whereas here we use the XML one. That just makes sense. So if you remember, we use a requests library and we do a .get to get the information, and we do a .content. So we get the content there. Without the .content, and let me just do a quick example. Without the .content, it gives you a code. There we go, a response 200. If you remember, 200 is good. I think 400 is usually that you didn't get the information that you wanted to get. And there's a bunch of other codes that they're all in Wikipedia if you want to look it up. But here I'm parsing my request through the XML parser, and I'm finding all of the items. I'm finding the item. So here you see in this search, what I want to get is the item. So if I had, multiple board games that come up in this document, each item would be its own element in the list. But since there's only one here, because here I only looked it up by ID3, again, you can look it up in different ways. But now I have each game or this game in this list. So my game is going to be in game 0. And this is the information that we're going to have to parse, which is a little bit different from how we would parse a dictionary or a JSON format. So to get the name, just as an example, the find all works in the same way as it does in HTML. So you just have to look for, usually I like to look for the first, basically the first word that comes after the open triangle bracket. So let's say I just want to get the names. I would do a find all just in case, because you can see there's different kinds of names here. Like you have samurai basically in different languages. So I would do a find all on the name to just get all the names just in case. And then the way the XML format works, which is actually like HTML, you have attributes. So sort, index, type, value, these are all attributes of the name. So now I have a list of all of these names. I only want to get the primary name. So basically to get the type, just an example, we can see that I'm doing the find all on name, looking at the first one, and I can pull out the type by doing like a dictionary lookup. So I get the type, which is primary here. And this was just out of like trial and error, but now we know the syntax to pull out an attribute's value. You pull it out like a dictionary. So now I can just do a quick filter. Here, all I'm filtering is just for wherever the type is primary, and I end up with the value for the name. And you can do a very, very similar process with other pieces of information. For example, if you want to get like the description, and I stored the game in games 0, the description, I would do a .find on description, and that is there. You can see it still has the open and close. And if you remember this, I believe it's .text. There we go. It's .text, and we get that out. But yeah.
So it's just the idea to just make that all into like a function, basically, and then just repeatedly scrape the different pages.
That's right. That's right. So with web scraping, your data is usually in one of two ways. Either each item is on a single page, like in this case, or in when I look up like a game, for example. I don't know this website. Oh, here. Basically, like all the information is going to be on a different page, and what you would end up trying to do is get some sort of like URL for every game or for every item, and then just have the same function work on every URL. Usually, you can also get URLs through like, there usually is a page like this where you can just scrape the URLs off of here. So for example, if we do a quick inspect here, it looks like we're able to get all of this information. So I'll probably do like a lookup of like each item here, and then get each of these like URL addresses to be able to scrape whatever it is. The other way that data usually gets shown on a page is you have multiple items on a page, which will lead me to my next example. But before I go to that, any other questions with what's going on here? Yeah, I definitely go more in depth if you go back to our phase 1 recording on like creating a function that will, get all your data at once. All right, let's move on to my next example, which is Craigslist. So Craigslist, I don't have that open at the moment. So Craigslist is an example where, everything is, each thing is its own. You have basically multiple items on a page. And what I want to be, the thing that I wanted to highlight when you have something like this is always scrape big to small. This is something that I also talked about when we talked about web scraping the first time. But always scrape big to small, because if you're looking for individual elements at once, you might end up with your different elements not matching. And I'll talk about an example where that happens. So what we're going to scrape is not AAP, but we're going to scrape the apartments one. Ooh, not here, but let's do it here. Oops. There we go. So we're just going to scrape all of this information. You can also get the URLs off of here. I forget if my function has that. So, all right. The first thing I'm going to do, and this is the important part, big to small. Just think about how granular is the information on the page. You want to keep all the information for one item together as much as possible. And I'll try and see if I can find an example of what happens if that is not the case. So when I'm looking up, here it is. When I'm looking at what should I scrape, I want to make sure that everything is going to be encompassed in one find all result. So for example, I know I want to get, like, for example, this image, maybe this title, maybe the price. I'm not going to directly look for, all right, let's just look for everything that says result price, or let's look for everything that says, like, what is this? Yeah, let's look for everything that says result heading. You want to look for something that encompasses all of the information together. So let's just see what highlights. See, this only highlights the image. So I probably want to go a little bit bigger than that, which I think is this. Yeah. So you can see here I have the result row, and these are each different items. So to just make sure that this image will always be together with this title, with this like neighborhood, I want to scrape this entire part first, or this is a thing that I want to extract first. Does that make sense to anyone? Let me know if anyone's unsure about what I'm trying to say. Okay, cool. So basically the implication of just searching up, this entire result row, which encompasses, it encompasses the image, the title, I guess the date, the price, the square footage. The implication of that is that I don't have to worry about matching them back up later on. So that is what this line is doing. Let me actually split it up into different parts. All right. Here we go. So when I have, and this comment goes with this, once I have this, you can see that that has already scraped. Apartments, let's actually look at the length of it first. I have 120 apartments straight off the bat. And the first of the apartments looks like this. So you can see that in this one result, of course, we have a lot of cleaning up to do here, but here I have the information of, where is that information? Let's see here. This is the title. Yeah, 12-minute walk from ferry, something about Staten Island. But yeah, you can imagine that the information is all there. I have the price of $7.50. I have, let's see, these are the URLs. If I want to go to the specific, the specific listing page, I know that's there. I'm trying to look for the title, but I guess we'll find it later. But now that I have all of this information together, you can do a list comprehension, and not a list comprehension, but you can basically write like a cleaning function to clean all of this up. So one thing that I realized when I was writing this really quick function is that not every place had a neighborhood. And so if I were to do the neighborhood the same way as this, so here you can see I'm doing this separately, which doesn't really, honestly, I should have done it all at once, but I'm finding the titles and prices because every listing has a title and a price. Neighborhood's not the case. Here, let me just run part of this real quick. Let's get the titles and prices first. All right, so with titles and prices, let's take a look at titles. So I guess the title of that one was 12-minute walk from ferry. Great. And we take a look at the length of that, 120. Let's take a look at the length of prices, also 120. So if you know how many items there are on a page, if there's something missing, great. You know that that is done. As an example, let's just see what neighborhoods has. I know that this is going to be a different find. Let's see where neighborhood is. So it's span and the class is resulthood. Oops, this one. Then type, all right, let's get rid of this. So there, we can see that neighborhoods, one, you have all of the results there, but I believe that some of them, yeah, some of them ends up as a none type. So therefore, I have that separate function for saying if it's not none, we're going to append none. Because there is a chance that if you were to do a find on this, yeah, it might be inconsistent. But anyways, what I was getting at is big to small. That's the main point. When you're web scraping, always go big to small. So you can see here, I'm just doing the neighborhood search per apartment. And then what we have here, oh no, where did this break? Let me just quickly rerun this or unrun this. There we go. All right. So now after that is done, we have our data frame of information from Craigslist. Any questions on that?
Web scraping for each website is the same, or for each different website is different, for example, based on the structure of their HTML website or something like that?
Mm-hmm. Well, the functions that you would use for each website are pretty much the same. Like most of the time, you're just going to use a find or a find all. So in terms of that, that's going to be very similar. Every website is structured differently. Like not every website is, you know, as clean as this. So I would say the methodology in which you have to first figure out, all right, where am I going to have all of the relevant information per row of data? That is going to be the same. But, you know, every website is structured differently. So in that case, the specific things that you're looking up are definitely going to be different. There are a couple caveats to web scraping that I also want to address at the end, but anything else about this? Cool. So a couple caveats. Let me just zoom into this text that I have here. So sometimes when, especially when websites are very, you know, when they have a lot of like Flash elements or JavaScript elements that like refresh a lot, for example, you might not find the exact information you want to scrape. You might find it on the page, but when you do beautiful soup, you might not be able to find the exact thing. That's just, you know, I don't know, advanced websites and those JavaScript elements tend to throw things off. So one library to help get around that is Selenium. And now Selenium is basically a library that allows you to control your mouse and keyboard to get specific information. So you can actually write code or write a program to have your mouse go onto every web page and like copy and paste a certain thing or extract the live HTML for something. I have not used Selenium myself, but a lot of students have managed to pick it up during the capstone. So it's definitely a possibility. I can help to like debug some things in Selenium, but I personally have not done my own project in Selenium. If for some reason you just hate beautiful soup, I know sometimes it can be kind of finicky and it's not, the documentation is not the best. There's another library called Scrapy that some students, not a majority to be honest, but some students have really enjoyed using Scrapy over beautiful soup. And it works in a very similar way. I believe some of the methods that I've seen Scrapy has basically, you do more in a single step, if that makes sense. It aggregates a lot of different methods all at once. So if you want to explore a new library, Scrapy is there for you. But yeah, any other questions regarding getting your own data? Cool. I want to mention that as long as you are using an API or web scraping, that is enough. You don't have to worry about like putting multiple APIs information together. You don't have to worry about like web scraping many different websites. you'll probably end up scraping more than one page just by the nature of websites. You don't have all your data on one single page usually. So yeah. Cool. With the remaining time, I wanted to talk about, what makes a capstone so great. And I'm going to do that by way of examples of past capstones. Of course, don't take this as like a bar that you have to reach. I just wanted to point out some of like the things that, me myself were impressed by, as well as I imagine like some people, I don't know, just like impressive things about a capstone that make people go like, whoa, when they see your capstone. So I'm just going to talk about a couple of the examples that like I really remember. And these are like, these are projects from like over a year ago. And the fact that I still remember them and like the things that make them unique, I feel like it's worth mentioning. So one of the capstones that I thought was really cool is this one. So this 3-tier recommendation system. Basically, this project was built with the idea of getting over the cold start problem. So you can see here, they suffer from the cold start problem. So this project actually had a 3-tier recommendation system. So based on your user ID, you would get fed a different recommendation system. If you have a brand new, if it's a brand new user ID, it would do non-personalized. If you like have some information but not enough, you will get routed to like a content-based. And if you have over a certain number of recommendations or a certain number of ratings, you'll be given like the SVD model output. I think that's pretty cool. This person actually wrote, this project was from almost 2 years ago, I think. No, I remember, it's like June 2019. He wrote like a couple of blogs on this, really like in depth. And you can see that he also built out like a front end to give recommendations. So yeah, because of that, just getting creative with ways to solve certain problems, I thought that was something that's really cool. Another one that I really like is this one, the playlist builder. So what's really cool about this is I was talking about you have to sometimes get creative with the way you want to use recommendation systems. And this project, as I think Adina, you were just saying that it's hard to get user information off of Spotify or pretty much out of any app. If you want to get like personal user information, it's usually one, very anonymized, two, it probably is in the data set that already exists. It's just hard to get like rating information. So this person looked to like basically found a way around that problem by proxying users and items for something else. And so in his project, I remember he'd use, I don't know if he says it here, but yeah. So basically ratings end up being weights and your items are playlists and the users, or I guess the user is a playlist and the item is an artist. So basically he gave each playlist artist value a weighting based on how much of the playlist is by that artist. So the utility matrix basically has different parameters than like, so it's not the usual user item. And I think that creativity was something that, I don't know, it blew my mind at the time. I don't know, any thoughts on those two recommendation systems? Cool. I have one more recommendation system one I wanted to talk about. Is it here? It's not here, but I'll talk about it because it's not specifically about the recommendation system, more so about the, I think it's another thing about creativity. So this person did a skincare recommendation system. It is not this one. I mean, this one's also really interesting to look at, but there's another skincare recommendation system where I remember she came to me saying that I want to find a way to do personalized skincare or like makeup or something based on a person's like genetics. And genetic information, as you all know, is very, very hard to get. Like, no, you just don't have people's DNA information. I don't even know my own DNA information. And so the way that she proxied that is she looked at like beauty users' profiles. I think on like Sephora or something, you have information You have information about like your hair color, your eye color, and she used that as a proxy for genetic information. So I thought that was really cool. Not about the recommendation system part. I mean, that was cool too, but more about like the way that you're getting over, you're just getting over data that you can't obtain, which I thought was really interesting. And yeah. Yeah, I am a big fan of recommendation systems. I feel like it's no secret. But yeah, I don't know my own DNA information either. But yeah, with the remaining time, I guess I could talk about some other projects. Some of the more interesting NLP projects that I've seen, I really like this semantic search project just because I don't know if anyone has taken a look at this, but basically what it was that he had trained a bunch of models to basically recognize like themes in stories. So if you want to just look up like, all right, if you want to look up something about like an ugly child or a handsome pig or something like that, if you basically the thought behind this was if you're trying to remember, I remember like this scene from a book, but I don't remember what book it is. You could just input stuff about this scene and then you can get the book result, which I thought was really cool. Very, very creative in my opinion. Another pretty cool one is a TV to book recommendation system. Honestly, the data that went behind it is not too complicated, but just the idea of using your like TV information to recommend books, I thought was cool. And there was like one thing where like he basically got over the fact that you would just recommend books basically if a movie was adapted from a book, you would recommend that book, but this does not do that, which is great. So yeah, I thought that was interesting too. Something that I want y'all to, of course, remember is that like all of the models that these projects are using are the models that we've talked about. These are not like crazy intense new models. Some of these projects are, like I know there's a couple like GAN, generative adversarial network projects that I have here. These are all like text generation projects, which we did not go through. So you're not expected to do that. A lot of these projects don't deal with that. Oh, some other stuff that you could see that make a project interesting. I like this one a lot because he had a really cool front end, and I think it's linked somewhere here. Don't know if it works right now. It usually takes a while. Oh, cool. It works. So this person, and this is created using the library Streamlit, which I will not go into detail about because I've never used it. It actually came out after I graduated as a student. But yeah, apparently Streamlit is really easy to put together. But yeah, basically he did it in a way that you can, interact and do this. So basically for each restaurant, this looks at Yelp and gets information from Yelp. You talk about food scores, stuff like that. He basically came up with this scoring system on his own. But yeah, lots of cool projects. If there's like if there's a particular industry or like, if you have like a project idea that you want to maybe see if people have done something similar before, let me know. I do have like a bank of projects that I can pull from. Of course, this bank exists in my head, so I have to like look up students' GitHubs, but yeah, let me know. I'm happy to source more projects as inspiration for you all. But cool. Any questions or thoughts or, I don't know, worries about Capstone? I know everyone's feeling a little bit anxious, but yeah, Capstone is, in hindsight, not that bad. I will say, usually when you're looking back on Capstone, you're like, oh, that wasn't too bad. But yeah, I understand as you're approaching it, it's a completely different mindset. All right, well, if there's nothing else, tomorrow we'll get into storing your data in a SQL database. I think that will be really exciting. It's a really neat way to incorporate SQL into your project. You'll see it's actually kind of simple depending on the methodology, but I know a lot of you want to be able to incorporate SQL because it is something that people look for. Being able to use SQL queries and being able to use that in your own project would be really cool. So we'll talk about that tomorrow. If there are any other questions, feel free to Slack me and let me know. But if there's nothing else, I will see you all tomorrow or at your upcoming project reviews. All right, bye everybody.
Thank you.